I'm really privileged to meet you, especially on this campus of Seoul National University. I'm very much excited about spending next 3 days to share yours and my experience and knowledge. You have quite a bit of expertise in each of your disciplines, even though most of you may not have been involved in pipeline engineering per se. So I have two missions or roles to play. One is to introduce the concept and process unique to pipeline system design. Okay. You may be familiar because when I look at your experience, yours is most likely in chemical process industry or something like that. Okay, pipeline is certain area quite different. So I may introduce some of new concept or different concept unique to pipeline and system design. And the second aspect is, since you have some experience like materials and steels and things like that, there is a certain area that I could synthesize some of the things that you are familiar with into pipeline system design, and to which you can contribute a certain area. Okay? So, but most of all, I'm deeply indebted to EDRC, particularly Professor Chung and team leader Mr. Unchul Kim, who introduced this program, and also these two gentlemen organized this event superbly. So I'm very grateful to that. Okay, so I will spend the next 3 days. I taught this particular courses at several universities and mostly many pipeline operating or engineering companies. Okay, but most of university audiences is quite elementary, or some have some intermediate knowledge. So I cover that. The difference between yours and then theirs is I cover this one full semester. That means about 14, 15 lectures. But now I have to shrink this one into 2 days, particularly design only. That means altogether we are talking about somewhere around 15 hours. Okay? So I have to shrink the whole thing to 1/3 of that. Okay? That was a big challenge for me, not only to prepare the lecture note, but also delivering in that in condensed manner. Second is the engineering company or operating company's employees or engineers understand the basic concept. In other words, basically they understand the basics or fundamentals of pipeline engineering. So mostly for them, I covered intermediate to advanced. Okay, so the limit, rearranging those scope is a tough call for me at least. But on the other hand, even though certain aspect is very advanced, but on the other hand, without that proper understanding of the system design is lacking, so that's why I include those. But okay, I rather introduce itself, but on the other hand, may not spend too much time. So, but on the other hand, okay, these with with two other friends of mine, we wrote a book because most of books are pipeline books developed. Only hydraulics, but liquid hydraulics is very simple. So, and also these days, software is well-developed. The software is abundantly available. So I wouldn't emphasize the calculation aspect, hydraulic calculation aspect. What I will emphasize, or what you can grab from me, is okay, what kind of variable you enter into the software. That part, hopefully, you could understand. Then you get quite a bit of that. But on the other hand, this one covers from introductory level all the way to advanced level. So, okay, this is about 650 pages long, so I cannot cover this one in 3 days. Okay, hopefully you understand that. So, scope is that I will not cover truly introductory level. That's why I sent you 3 prerequisites, okay, beforehand. Hopefully, you glance them over, okay? And then also in the syllabus, I mentioned that configurations expansion, in other words, pipeline expansion in certain ways. And the other one is in certain operation, you have to blend the product. That aspect is considered advanced, but on the other hand, for future reference, it may be helpful for you if you are involved in that kind of design activity. So that's why I sent that one to you. But on the other hand, it's a little bit difficult for you to understand. Then ask me. And also, the other one is, because I'm living in Canada, so I won't come, it's quite an effort to come all the way to here. So I may not have ample opportunity to meet you. So what I suggest, this is all unofficial, not through EDRC, because if there is certain official channel is open, then some legal aspect is involved. So that's why I like to avoid those kind of things. Okay. So in person to person, you can send me your questions or email through email. Then I will try to answer as much as I can. And also, this book is copyright of this book belongs to ASME, not mine. Okay. As a result, I cannot share everything that is in the book. I may edit some of them and then may pass on to you. Okay. So if you have certain specific questions. Okay. So that's sort of brief introductions. Any questions about that so far? Yeah, I was warned that you guys are relatively shy, so you may not ask any questions. But I left my Korea long time ago. They, even your parents may not have been born at the time. So okay, I'm used to that North American culture. As a result, I hope I may not sort of okay, hold you wrong side. Okay. Okay, let's look at this. I used to be a sort of this cartoon geek, but okay. Look at this, my favorite cartoons. Okay. Sam probably dreaming about all these doggy friends. Okay. Then this Sally says, no, I will bet he's dreaming about us and all the people he likes. Okay? But what about dog itself? He's thinking of this. Okay? So I hope I'm not this kind of dog so that I don't understand what you are thinking of. Okay? Hopefully, through your feedback, I could understand what kind of things you like to know. Okay? So that's the message I like to convey to you. Okay? So please ask as much as you can. Okay? Okay, first, I will cover this fundamentals of hydraulics and pipeline system design. Okay? So even though I sent you 3 prerequisites, they may not be sufficient, and so in certain respect, yes, it is. But there are certain aspects you need to know. So that's why I bring the fundamentals of hydraulics. Hydraulics in liquid is very simple, and also pipeline system design. This is a kind of a process. Okay, what kind of process we follow? Okay, then second things, it says isothermal flow design. Okay. In most of cases in pipeline, liquid pipeline design, this isothermal aspect is good enough, not in terms of accuracy, but on the other in the concept itself, okay, and also process itself. So, but on the other hand, it's much easier to understand the concept with isothermal process. Okay, that's why I come up with this one. But there are a few exceptions. So, for instance, the heavy oil is highly dependent on temperature aspect, so I will cover that aspect. The other one is light hydrocarbons like propane, ethane, ethylene, that type of things. Okay, so propylene. So I will bring those aspects in thermal flow design. And then particularly transient analysis, this is sort of more intermediate or even advanced level of content. But on the other hand, first day and a half or something like that is all steady state approximation. But anything operation related aspect is a bit of considered advanced level. And without understanding, proper understanding of operation, system design doesn't mean much. Okay? So for that, most critical one is transient analysis. Okay, I will introduce the concept and what are involved. Okay, so that's I'm going to cover next few days. Okay, this is sort of North American business jargon. Okay, devil is in the detail. What does that mean? Anyone? Devil, you know what devil is. Okay. Devil is in the detail. Anyone? Any guess? Okay, in business in North America at least, what it means by that is some trouble or problem occurs in detail level. Not only in engineering, but also in contract and in many business aspects too. Okay, so the reason that I put it in here is the concept, the one that I'm going to cover next 2-3 days is mainly concept and then process itself. But what's deeply inside of that concept is important. So your job is to find out, or if you have some kind of sort of tragic failing, then you gotta mention to me and then explain to you. Okay? Is that reasonable? Okay. Okay, let's go. Okay, when you go to engineering school, okay, when you study engineering disciplines, what your professors teach you or taught you. Here is a primary, not on just the responsibility, just primary. Okay, number one responsibility of an engineer is safety. Is that right? Okay, I'm sure you have a Korean standard too. Okay, what standard is really means. Okay, that's they will define minimum requirements for safety. All aspects of engineering has risk, but you have to reduce the risk. Okay, and so primary, again, I am reading this one. Primary responsibility of an engineer, all of you, is safety. Okay. Then, therefore, the prime consideration in the design, construction, and operation of the pipeline system is safety. Okay. I hope you forget this one. Okay, so safety. But then with that, we'll introduce several safety factors as part of the design. Then, next most important things, not the primary, secondary most important thing is economics. Scientists focus on why questions, and the engineering, all of you engineers, how. So how economically we can design and operate. Okay, so second. So here, what you get out of this one, at least this morning, okay, I'll emphasize safety aspect in pipeline system design first. Then next one will be all economics related. Do I mean that then I will cover all economics? Unfortunately, no, okay, because I'm not an economist, okay, and all economists the job is to bring the economic aspect, okay. Then they will bring all economic related design parameters. Then engineers, within that framework, we come up with a system design, okay? Basically, my course objective is just for you to understand the basic liquid pipeline hydraulics. Again, liquid hydraulics is very simple. So I will put just one equations, okay? Very simple equations. And then pumping requirements and pipeline system design. After this one, I found that one person was a purchaser. Who is this purchaser? Okay, no? Okay. So When we finish pipeline system design, and we call economically optimum, then what you will get is very simple one: pipe diameter, pipe thickness, okay, and then pipe grade, okay, and then pumping requirement. That's all we come up with from the system design. Most of you are working for process area, then you use term DBM, Design Basis Memorandum. Okay, so basically that's what we're talking about. The way that we look at from hydraulic sense, not mechanical sense. Okay? Mechanical sense is more safety oriented, based on what hydraulics come up with. Okay. So after we come out, finish this one, hopefully you could identify what the pipeline grade would be most economically optimum, and the pipe diameter, wall thickness, and pumping requirements. Okay. Then the scope. Okay. Here is a refined petroleum product. I know that you have a refined product pipeline here. Daehan Oil, Daehan Oil Pipeline Company or something like that. Okay? So as a matter of fact, I was involved in TBM development of that pipeline system about 26 years ago, okay? And then high vapor pressure liquid. American is called, instead of HVP, they call HVL. H means highly, V for volatile liquid. Okay, so they call HVL. Okay, and HVP is more international, I think. And the third one is crude oil, including heavy viscous fluid. Okay, in the world, the most abundant petroleum sources, except the shale oil, that's a different animal altogether, but lots of heavy crude. So we'll talk about this one briefly as part of liquid pipeline system design. And okay, one of the decision I have to make, shall I include this pump and pump station design? Then that itself is a minimum half-day course. So within 2 days, it's impossible to include that. And also, I'm sure in process, you understand what how pump works, and particularly centrifugal pumps design type thing. So I decided to take it out, but only essential part is included in this course, okay? Then, pipeline, there is so-called multi-phase, okay? In cross-country pipeline, there is gas phase, liquid phase, and even solid phase mixed together and moved along. That's another thing. And also some two kinds of liquids. One is miscible liquid, the other one is immiscible liquid. That's a separate phase again, that type thing. And then mechanical design aspect, okay, that's is taken out, mainly because time is another one, but I'm not a specialist on this one, okay? So somebody else who is familiar with the mechanical design part has to explain that. And measurement and control, and pipeline operation. But without pipeline operation, it could be meaningless. So most critical aspect of pipeline operation is included. Control aspect, basic level of control aspect, and also so-called batch pipeline operation aspect is included here. Okay? Any question up to now? Do you have any violent objections that this is not what I expect or something like that? Okay. So shall I go back to the second slide? Do I understand that what you're thinking of? Not like, I don't want to be like a dog in the end. Okay. Okay, there are a few simple definitions. There are lots, but on the other hand, these are the few basics. One is pipe versus pipeline. Pipeline, when we use pipeline, you know, pipe is metal conduit, the closed conduit stuff. So it's simple. But pipeline itself, the meaning of pipeline itself is kind of system sense. In other words, pipes and valves and pumps and all those kind of things put together is called pipeline. Okay, pipeline. Okay, or pipeline system for specifically. Okay, and then base pressure. Okay, base pressure and base temperature means in North America at least, base pressure is 1 atmospheric pressure. Okay, so that's what base pressure. That's for custody transfer purposes. For instance, we call common carrier pipeline companies here. Then multiple companies put in their product into pipeline. Then one single company carries, a pipeline company carries that. It's called common carrier. Then custody transfer takes place. In other words, for instance, I saw some Hyundai oil, assuming that they produce some gasoline, diesel, or something like that. They put it in this particular DOPC pipeline. Then custody transfer takes place. In other words, ownership change, responsibility of owning this. Okay, still Hyundai Oil owns that, but on the other hand, the transporting responsibility now belongs to this pipeline company. So in between, custody transfer takes place. At that time, you have to have a reference. Okay, there we use the term base pressure and base temperature. Okay, base temperature could be, base pressure is almost universally accepted everywhere in the world. But base temperature, for instance, in Canada, 15 degrees, and many parts of Europe in 15 degrees. United States is 60 degrees Fahrenheit, means somewhere 15.5 some degree C, so slight difference. When I was doing some consulting work in Brazil, and they used 25 degrees as a base temperature. Okay, so as a result, base temperature could be different. Then pipeline transport, liquid mixture of this one. You all know this one. Okay. Pressure in pipeline. Okay, I won't go over this all detail because this one is mainly for completeness. In other words, there's for you to understand what this, when I say certain things, what do you mean by this in pipeline? Okay, always when fluid is moving, particularly in closed conduit like in pipeline, then okay, all along there is some stress is being developed, and then that one is translated into pressure loss, and that kind of things will be talked about in this course. Okay, and code and standard. Okay. Okay. Since I'm not familiar with Korean standard, so okay, I cannot talk about this one, but I'm familiar with Canadian standard and also ASME standard and some US regulation and Canadian regulation. So all my discussion will be using this ASME. Okay? Because ASME, I did my consulting work almost 30 different countries, and they all have in common, okay, ASME B31.4 is accepted as their standard. And for instance, DOPC, finally we settled to use P31.4, ASME P31.4. So including in Korea, that's what we use, okay? So what this one is, basically a standard code, code and standards, or CNS, is basically for minimum requirement for safety. Don't forget, this is the minimum requirement for safety. For instance, California, okay? ASME P31.4 is applicable in whole, as a whole? No, because California is earthquake-prone zone. Okay, so they have a specific regulation, government regulation. Okay, so their geotechnical regulation could supersede the ASME code because ASME or any code and standard is meeting minimum requirements. Okay? But in California, that minimum requirement is much higher. As a result, P31.4 is not applicable, that kind of things. Okay? One thing, okay, code and standard itself doesn't have any legal authority on it, okay? So what I mean by that is that, for instance, government issue regulation, and then it says you shall use ASME P31.4. Then at that point, that itself has a legal authority. Okay? In other words, all government regulation has a legal authority, not the standard code itself, unless it's specified as such. I mean, given legal authority is given to it. Okay, quite often I will refer this one, 49 CFR 195. CFR means Code for Federal Regulation. Okay, 195 for hazardous liquid pipeline. Okay, 192 is for gas type things. And then I use this one quite often. And then the rest of this, and also pipe specification is 5L, and 5L is more umbrella type code. And then underneath, 5LX, 5LS, but I use 5LX because pipeline engineers use 5LX most often, okay? Then API 60, those kind of things is very little we can talk about, okay? Component. Okay, since you are involved in engineering companies or these operating companies, I assume. So I'll talk about this component in detail, also time limitation. As a result, I will skim through, except the pipeline itself, okay, because pipe itself. Okay. Steel pipe. The course title, I say that liquid transmission pipeline. Okay, what transmission pipeline means? Transmission pipeline means mostly it's a long pipeline. Okay, so for instance, DOPC is a transmission pipeline from Ulsan all the way to near Seoul, and the other one is from used to be Yeocheon, but I understand it was combined with the Yeosu or something. So from that refinery all the way to Seoul, okay, near Daejeon, it sort of come together, okay, in parallel. So that's a transmission line. It's a long pipeline. That's what the implication is. And all steel pipe because pressure is high. Okay, for instance, DOPC pipeline, I don't remember exactly, somewhere around 900 psi or 6,300 kPa, that range. By the way, what kind of unit do you use here? kPa? SI is kPa, right? Yeah. Okay. And then joint and fitting, valves, meter station, pump station, pigging station, terminal, and storage tank. Have you heard of pigging? Okay, why they call pigging? Sound? Okay. Another one? Okay, anyhow. Okay. So I will briefly mention this one, but I won't discuss this one too much in detail. Okay. Okay. Up to now, all transmission pipelines, since it operates at higher pressure, 8 or 900 psi is about, psi, so 8, about 5,000-6,000 kPa to even higher than about 10,000, even 14,000 kPa type range. So plastic pipe is not applicable here. Okay. So all steel. Okay. Joint. Okay. In pipeline construction industry, the pipeline construction industry is well automated because it's very simple in automation, because many things is mostly involved in the welding and then testing whether there is any welding defects or something like that. So it's automated last almost 40 years. Okay. So this automation is done. Thread joint is seldom used in transmission pipeline as a joint, and flange is quite often used. Okay, like this. Fitting. There are many different kind of fitting. I'm sure that you are more familiar with that. Okay, meter station. Okay, meter station is required at the custody transfer points, and quite often depends on the contract. 2 meter station, one on the owner or owner side. The other one is pipeline owner side, pipeline operating company, those type things, because there is a clear sort of protocol between 2 meter stations. Okay. Then, for instance, DOPC, it used to be what we specified was turbine meter. Turbine meter was most popular and still is most accurate as far as I know. Then positive displacement meter for heavy crude, and Coriolis meter, that's a mass meter, not a volume meter. That's recently, last 20-some years, Coriolis meter is widely used by more expensive product, particularly any custody transfer takes place in mass. Okay, for instance, ethylene, our custody transfer takes place in kilogram or pounds, something like that. Okay, and then last 20 years, 1997 or 1998, ultrasonic meter become custody quality meter. So as a result, this one is cheap, maintenance is very inexpensive, and accuracy is comparable to positive displacement meter or Coriolis meter, not quite as accurate as turbine meter. So ultrasonic meter is getting popular. Okay, yeah, this one is a typical ultrasonic meter here, and then this we call meter runs. Okay, so it's quite simple. As a result, for instance, this one it cost about $250,000 instead of $1 million pop, that type of thing. Okay, so because of the cost and also accuracy is there, maintenance cost is quite low. So ultrasonic is getting popular more. Pump station. Okay, in this case this is open pump station. The other one is housed pump station. You know what pump does. So okay, here, because of not the operating companies but engineering company who could work in high octane or something like that, then you may need a cooler or chiller. Okay, I was involved in we call the Norman oil pipeline in the Arctic, and because when crude oil is being transported, flowing, then heat is generated because the friction heating, Joule-Thomson effect and all those kind of things. So surrounding pipe is getting hotter, about several degrees higher. In that case, surrounding soil is frozen, then what will happen? Pipe could buckle. Okay? So to avoid that, you have to chill the crude oil, let's say minus 5 degrees C or something like that. That way, after transporting a couple of 100 kilometers, still it couldn't melt surrounding soil. That's why there is a chiller, okay, that type of thing. Okay, valve. In pipeline, valve requirements is relatively simple. Okay, for instance, this is a block valve. Then the requirement is that peak has to pass through. In other words, full bore valve. Okay, so like a gate valve, something like that is not applicable because peak cannot pass through. Okay? So like a ball valve or gate valve, that kind of thing is suitable. Okay? And other than that, valve requirement is relatively simple. And the applications, of course, this one is a mainline valve is one thing, and some check valve type things here. Check valve is two aspects. One is that in pump station, a check valve is required. Okay, we'll talk about that when we're talking about transient, addressing the transient aspect. The other one is that when line rupture takes place, then we call EFRD devices, emergency flow restricting device. Okay, a check valve can be used to arrest that further damage or leakage. And pressure regulating and control valve, that kind of things, we'll talk about that when we talked about so-called slack flow. Okay, pipeline is quite often operated in full flow. In other words, inside of the pipe is full of liquid. There's no vapor is allowed. Okay, so because of that, there is multiple design factor is involved. And then because of that, to avoid any potential pressure drop below vaporization pressure, then we use pressure regulating valve or sometimes pressure regulating station. Okay. Pressure relief valve. Again, we'll talk about this one tomorrow afternoon when we talk about how you control the high or surge pressure or that type of things. Okay, ball valve is most popular for block valve type things. The other one is gate valve because this is a full bore valve. This one is tooth. Butterfly valve and this one for control. And glow valve is also for control. Okay. And for large flow like this one is also quite popular. But on the other hand, if flow velocity is very fast, then the for large pipe, then momentum is really big as a result. This disc may not have a strong enough to handle that kind of huge momentum. Okay, pressure regulating valve or sometimes pressure regulating station. Okay, PRV is what is it? It's going to try to reduce the pressure downstream. Okay, pressure upstream rather than downstream. Okay. Okay, it looks like this. Okay, how it works is that when you're looking at this, they sense some pressure, okay, downstream side, then it will restrict. As a result, this pressure downstream side is much lower, so that further back pressure could be reduced, so that they can avoid potential so-called slack conditions. We'll talk about that probably this afternoon, late this afternoon. Okay, so that kind of device. Pig and pigging station. Okay. Okay, this may be unique to pipeline side. There are multi-purposes. Okay, also different type of pig itself. Okay, one is cleaning pig. So basically, it has a brush in it, and then batching pig. When you send two different products to avoid any intermixing between two, you put so-called batching pig, and then caliper pig. So, for instance, pipe is a little bend or something like that. You detect that kind of things. Geologically unstable area, then they run caliper pig quite frequently. And then inspection pig. This one is quite expensive, and then check inside of the pipe conditions, okay, whether there is any corrosions or crack is developed, things like that. Okay, this one is actually cleaning pig. Can you see the brush? Okay, inside. Okay. The reason we do this one is by cleaning, you can increase the pipeline efficiency. How? Because we have pipe roughness. Okay, if it is some wax or some kind of debris is built and sticking onto the pipe surface, then it impedes flow. As a result, transmission efficiency drop. So then you send this cleaning peak so that you have a very clean pipe, and also roughness is quite uniform. Okay. The other one is this one is another cleaning peak. So basically, the purpose is different. For instance, gas line, you have some kind of liquid drop out or something like that, then it cleans things up. Or some other solid elements, things like that, then you can clean things up. And this one looks like a batching peak, and then this was the inspection peak. Okay? So this one is currently two types. One is this one is huge, high strength magnet, so that you can generate a big magnetic flux, and that's how you detect. The other one is ultrasonic, so that ultrasonic is mainly for crack discovery, and magnetic flux type is more corrosion type discovery. And the terminal. Okay, there is tank terminals and manifold and all those kind of things. So I'm sure there are multiple type of terminal. This one is sort of you may be familiar with when you go to Ulsan or what is it, Yeosu, then you may see this kind of terminal. The other terminal is this is a typical North American type terminal. Okay, we call gathering. There is multiple pipeline companies have multiple their own tank. For instance, Enbridge has their own tank, and Gibson Energy has their own tank. Husky their own, and Spectra has their own, things like that. And then it's all gathered together. Then a pipeline comes from many different parts, and then all gathered together here. Then a huge pipeline, for instance, 40-inch, 36-inch pipe carries from here to other parts, all the way to, in this particular case, to the United States. Okay, tank farm, I'm sure. Okay, I worked on this East-West pipeline, world's largest pipeline system, and daily capacity 5.2 million barrels. Okay, one is 56-inch line, the other one is 48-inch line. It's going parallel. It's a huge pipeline. Okay, so when you look at that, their tank, one tank itself is a 1.2 million barrel or something like that. Okay, world's largest tank. Okay, but it's very hot, so as a result, they pump water to cool the tank, things like that. Okay, this manifold is all over the place in that area. It's very, very impressive. Okay, so from now on, we call design element or some design factor, so it doesn't matter too much. This is, I introduced through this what are required for system planning or system design. Okay, this you may find out, these are quite different from other types of piping or something like that. Okay, so that's what I'm going to do.